Imagine floating hundreds of kilometers above Earth, seeing the blue planet spin slowly beneath you. Right now, humans can live in only two places in space: the International Space Station, or ISS, which has been orbiting Earth for over 20 years, and China's Tiangong space station, a new but rapidly advancing rival. Both are incredible engineering achievements, but how do they truly compare, and what can we learn about life in space from them? Let's start with their altitude. The ISS orbits Earth at around 400 kilometers above the surface. At this height, astronauts experience 16 sunrises and sunsets every day, completing a full orbit every 90 minutes at a staggering speed of 28,000 kilometers per hour. Tiangong orbits slightly lower, at about 389 kilometers, but it's equipped with advanced ion thrusters. These thrusters allow precise orbital adjustments, making it more energy efficient and stable over long periods. For long-term missions, such control is crucial to maintain a safe and steady orbit. Size is a major difference between the two stations. The ISS is huge, with a living space of 388 cubic meters, like a 6-bedroom house floating in space. It took over 30 missions and more than 10 years to assemble, starting in 1998. The station spans an area roughly the size of a football field and usually houses 6 astronauts at a time, sometimes more during crew changes. Tiangong is smaller, around 110 cubic meters, enough for 3 astronauts. But it's efficient. China built and assembled the station in just 2 years with about a dozen launches. Compact, but highly functional. The way these stations are powered also differs. The ISS uses large solar wings that convert sunlight into electricity, producing enough energy to power more than 40 homes. Tiangong has smaller, more advanced solar panels made from gallium arsenide, which are more efficient than the silicon-based cells originally used on the ISS. Both stations store extra energy in batteries to continue operating while passing through Earth's shadow. Tiangong's system was optimized from the start, whereas the ISS upgraded its energy storage over time. The internal structure of the stations shows different design philosophies. The ISS is divided into 2 main sections, the Russian orbital segment and the US orbital segment, along with contributions from Europe, Japan, and Canada. Each segment has living areas, laboratories, and workspaces. Tiangong is built around the Tianhe core module, containing life support, control systems, and living quarters, flanked by 2 science laboratories. Though smaller, the design is highly functional and modern. Technology on board is fascinating. The ISS has robotic arms that help assemble the station and now assist with experiments, repairs, and spacewalks. Tiangong goes further, with 2 robotic arms that can crawl along the station like mechanical spiders, moving between docking points. One arm can lift up to 25 tons. There's also a backup control system built into its lab modules, so if something fails, operations continue safely. These features make the station safer and more versatile. Life on board is another point of difference. The ISS, despite being iconic, looks a bit cluttered with decades of cables, equipment, and research experiments. Tiangong, being newer, appears sleek and modern, like a high-tech apartment. For astronauts who live in these stations for months, a clean, organized environment improves comfort and efficiency. But the story doesn't end there. China is aiming higher. They plan to land humans on the moon by 2030. The Long March 10 rocket, the Mengzhou crew spacecraft, and the Lanyue lunar lander are all under development. Tests are underway, prototypes are being built, and the pieces are rapidly coming together. The Long March 10 is more powerful than any previous Chinese rocket and will carry astronauts and cargo toward the moon. Mengzhou will transport crews safely with upgraded safety and life support systems. Lanyu will land astronauts on the moon, offering short-term habitat and mobility with a small rover for exploring the moon. The missions are designed carefully. After launch, the lander enters lunar orbit, docks with the crew spacecraft, and transfers astronauts. Then, the lander descends to the moon in stages, with engines and thrusters ensuring a safe landing. On the surface, astronauts will carry out research, explore craters, and test new equipment, all while relying on built-in safety and redundancy systems. Every detail, from engine layout to surface rovers, is engineered for precision and safety. So what does all this mean? The ISS represents decades of international cooperation and achievement, a symbol of humanity working together in space. Tiangong represents rapid innovation, efficiency, and China's ambitious plans for the moon. Together, they show how human spaceflight is evolving, faster, smarter, and more competitive than ever. Imagine looking out of a space window, seeing Earth's curve against the black sky. In the near future, humans may stand on the moon and look back at Earth, with these space stations forming the stepping stones to explore the solar system. The race for space isn't just about technology, it's about vision, perseverance, and the next giant leap for humanity.
Human rights are not just words written on paper. They are the heartbeat of our humanity. They belong to every man, woman, and child, no matter where they are from. But rights mean nothing if we stay silent. So let's raise our voices together, stand for justice, speak for those who cannot, and never forget that protecting human rights starts with you. If you believe in equality, dignity, and freedom, share this message, subscribe, and join the movement. Because a better world is possible if we build it together.